Hi, I'm Dr. Samantha Lawler. I'm a professor of astronomy at Campion College and in the Department of Physics. I study small bodies in the outer solar system, like Pluto, and I use those to try to understand whether or not there could be other unseen bodies, like the hypothetical Planet 9. So this is a giant planet that's theorized to be very far out in the outer solar system that we haven't discovered yet, based on the orbits of very distant Kuiper belt objects. So I test theories like this by trying to find new Kuiper belt objects, which I do by looking. I take a picture of a spot on the sky with a large telescope like the Canada-France-Hawaii telescope, take a picture again a couple hours later, and again a couple of hours later, and see what moves. And those small fuzzy moving dots among the stars are Kuiper belt objects, and by tracking them I can learn about their orbits, and some of those orbits are pretty amazing. So Pluto and Neptune, for example, have this really impressive relationship between their orbits, where Neptune goes around the sun exactly 3 times in the same amount of time that Pluto goes around the sun exactly twice. And so on the left side of this animation, you can see that Pluto and Neptune actually cross each other's orbits, right? So why don't they ever crash into each other? So on the left side, you see just what you would expect to see looking down on the solar system. So now imagine that you're above the solar system and rotating at the same speed that Neptune is orbiting. So Neptune is staying in the same place. So then on the right, you see what Pluto's orbit does relative to Neptune, right? And so you can see that whenever Pluto comes in closest to the sun, whenever it crosses Neptune's orbit, it's actually as far away as possible from Neptune. And that's because of this special relationship between their orbits. And this is also telling us that these orbits are sort of dynamically connected to each other. So this is telling us something about the past history of the solar system. It's telling us that Neptune actually moved in its orbit, and as it did, it swept up many Kuiper belt objects into special orbits like Pluto's. So I tried to learn about the Kuiper belt and about the history of our solar system, but that's becoming increasingly harder and harder due to satellites that are being launched. Just in the last 2 years, the number of artificial satellites has increased by 50%, mostly due to the Starlink mega constellation. And this is projected to get much, much worse in the next few years. The stars are still going to be there, but we will be looking at them through an increasing number of satellites. So the beautiful images of space that we're used to seeing will all have these bright streaks from satellites moving through the field of view, and that's going to make the entire field of astronomy much harder. So I am also looking at ways, trying to understand what this means for the sky and how we can possibly mitigate this effect. So here's a simulation that I made that I'm working on right now. So this is looking at the night sky from 50 degrees north, so right here in southern Canada. So this is sort of an all-sky view showing how many satellites will be visible in the sky. So the ones that are orange and yellow are the ones that are visible at different times of night. So here at 50 degrees latitude, we're actually at just about the worst place on Earth for light pollution from satellites. So by trying to understand what's coming and try to make people see what they might be missing by this unregulated development, I hope that I can keep the night sky somewhat pristine for astronomy and for stargazers everywhere. So if you're interested in the outer solar system, or learning more about satellites, or or any other topic in astronomy, come talk to me. I would be happy to chat.